And for what it's worth, in the last problem of the textbook, the 7th edition seems to have an error. You can check the one I just did against their example, but I believe they made a boo-boo. Well, you know, you have that sometimes. But anyway, I was able to catch it, and this I believe is the correct version. And sorry about running out of space up here with this one line. I don't think I can do anything about that either. Okay, so another example. Let's look at another example. And here's our other example we're going to look at. We're going to solve a differential equation this time. That's great. We're going to actually get the whole thing. So it's a second derivative y minus 6 times y prime plus 9 times y is equal to t squared times e to the 3t. How about that? So maybe we'll try to work our way through this one. Great. All right, that's what we're going to do. So, we have some initial conditions. You know, we need 2 initial conditions at 0 in order to find the Laplace transform of the second derivative. So, in pieces, since it's linear, we want the transform of y double prime minus 6 times the transform of y plus 9 times the transform of 6 times the transform of y prime minus 9 times the transform of y is equal to the transform of t squared times e to the 3t. You see the 3t will be a displacement. I hope. Anyway, so with that said, don't know why my software is acting funny, but so s squared y of s, that's, you know, in the transform of this, s squared y of s minus s times y of 0, which is eventually I'm going to replace that with 2, and then minus y prime of 0, I'm eventually going to replace that with 6, minus 6 times the transform of y prime, well, that's s times y of s, minus y of 0, which I'll eventually replace with 2, and then plus 9 times y of s. And now what about the transform of t squared e to the 3t? Well, the transform of t squared would be 2 factorial divided by s cubed. But this is displaced by this 3, so it's going to be 2 divided by s minus 3 cubed. Now this is a nasty looking thing, but we can solve this for y of s, and that's the algebra part. Admittedly, sometimes tedious, but doable, right? Not that hard algebra. So this is 2, so there's y, or negative 2s. This one, where is it? This was 6. Oh, help me. This was 6, so we'll replace that with 6. This we're going to replace with 2. And when we do that, you can probably see why we get this line. Okay? So we'd want to factor the ys out. Over here on the left side was y of s times s squared minus 6x plus 9. And then we also have this minus 2s minus 6. The minus 6, I'm sorry, plus 6, because there's a minus 6 here and a plus 12 here. So that should be negative 2s plus 6 equals 2 over s minus 3 squared. And solving this, okay, continuing to solve, I should say, add the 2s, subtract 6 from both sides. And so we're going to end up with y of s is 2 over s minus 3 to the 5th power, because this is s minus 3 squared, so we divide by another pair of those, so we get s minus 3 to the 5th. And this is 2 times s minus 3. When we divide that by s minus 3 squared, we just wind up with 2 over s minus 3. And so look, this is direct translation for a solution. Don't know why the book answer doesn't match it here, but it should, and I'll verify that my answer is correct. And again, the book has a flaw, but this 2 over s minus 3 to the 5th. Imagine if it was 2 over s minus 3 to the 5th. Let's just say if it was 2 over s to the 5th, then, you know, we need a 4 factorial in the numerator, so we'll just multiply it and divide by 4 factorial. So we'd have 2 divided by 4 factorial times the Laplace transform of t to the 4th. But it's displaced by 3, so we'll multiply by e to the 3t. And this one's kind of simple. It's just going to be twice times the Laplace transform of e to the 3t. And if you simplify all that, this 2 over 4 factorial is 2 over 24, so 1/12 t to the 4th e to the 3t plus 2 e to the 3t. Okay? Book answer doesn't match, but guess what? I checked it. I checked my answer by taking the second derivative minus 6 times the first derivative plus 9 times the function. And when I checked my answer, I got t squared times e to the 3t. So my answer must be correct. I think in the book, their right-hand side has a 2s plus 5. It should be 2s minus 6. That would be here. Or, yeah, that's probably the difficult spot. So I don't know where they came up with a 2s plus 5, but I think it's obviously an incorrect answer.